Welcome back to Unit 7, Lesson 1. This is part 2 of the video, and this part's optional unless you've missed class. So we talked about the plasma portion in part 1 of the video. Now we're going to talk about the cell-based portion of blood. This is approximately 45% of your blood volume. And it contains several different cell types. The first one, the one you're probably most familiar with, are your red blood cells. And important to the red blood cell is their shape. So they are what's called a concave disc. And in class, you can come over and take a look at Ralph. Even though he's a stuffy, he's a good representative of the shape of a red blood cell. So concave disc lacking nuclei or nucleus and most organelles. So why they only live for 120 days. Because the vast majority of their space is of volume is taken up by hemoglobin, which is a protein that's complexed with iron. To carry O2 and CO2. And that's their main job, is just to transport O2 and CO2 back and forth through the blood. And this biconcave or concave disc shape helps it to flow better. Another type of, it's not really a cell, it's more cell fragments. It comes from a larger cell that breaks down, and you don't need to know the nature of that larger cell, but are called platelets. And their job is for blood clotting. So they work with fibrinogen and several different factors to, if you're injured, cause your blood to clot. And then we have, oh, by the way, if we go up to red blood cells, they're also known as erythrocytes. So that's another name for red blood cells, erythrocytes. We come down here, the next three cell types, if you look at them, they have something interesting about their nucleus. They look like they have multiple lobes to their nuclei. So they all get grouped together in what we call granulocytes. And granulocytes basically help your immune system. And they do various functions. They release histamine, and what's called heparin, which actually thins your blood to increase blood flow which leads to inflammation. So if you have a wound and it's all red and puffy around it and it feels hot, it's usually because you have histamine and heparin being released by granulocytes, and it's to encourage blood flow so even more white blood cells can get there and fight off the infection. It's also associated, unfortunately, histamine, if you release too much of it, is associated with allergies, and this is why if you have allergies, you take antihistamine medication. And they also have one more job. When they float there, they do phagocytosis, and they're used to fight off parasitic worms, bacteria, fungi, and viruses, all of which are considered pathogens, things that we want to take up and destroy out of our body. Those are granulocytes. The last two are called agranulocytes because they don't have these apparent granules that you see under the microscope with the other ones. They're also called lymphocytes. And there's two main classes. You have your T cells, which mature in thymus, which is an organ in your body which helps produce your immune cells. And their job is to attack and kill microorganisms, so like bacteria, and also tumor cells. So your body does try to fight tumors off. It's not always successful. The other type, my favorite, because it's what my PhD is in, are B cells. And these are produced or matured in bone marrow. And their job is to produce antibodies that target invaders, which are more appropriately called pathogens, for destruction. And if we consider both the agranulocytes and the granulocytes together, these are called your white blood cells. Okay, and then of course you have your red blood cells and your platelets. Okay, so just down here, if you need to finish that off, I'll hold that on that screen for a second. And now the question many of you have been asking me about, what do we mean by blood type? And blood type refers to a particular type of protein on the surface of blood cells. That can vary from person to person. And the interesting thing is that these proteins can cause an immune response in a person who does not normally have them. So their immune system will attack any cells with these proteins on it. And anything in your body that causes an immune response is called an antigen. So we're going to talk about the protein type is the same as the antigen type. So the ABO system just refers to two different types of proteins you can have. You can have A or B or both or neither. O is not really O. O is 0 for you don't have either of the antigens. So let's take a look. If you have blood type A, this means if this is your blood cell, on the surface of it you have a protein that we call A. And I'm just going to go A. So remember when we were talking about different functional classes of proteins? And you have thousands and thousands of different proteins on any given cell surface. But if you are blood type A, then you have antigen A on your cell. Okay? Your body will not produce antibodies to protect or attack, A, because that would make sense. You'd be killing your own cells. What it will make antibodies to is the B antigen, because you don't have that in your body, and if the B cell or B antigen carrying cell gets into your body will want to attack it and assume that it's foreign. Okay. In contrast, if you are blood type B, it means you have on your cell surface protein that they have named B. So that's a cell, and I'm just showing on its cell surface that it has protein B. Now if you have protein B or antigen B, you are not going to produce antibodies against your own cell, but you will produce them against the type you don't have, meaning in this case it will produce antibodies against any cells that have the A antigen. And some people actually have both A and B on their cell surface, so they're called AB. And because they have A, they won't make antibodies to A, otherwise they'd destroy their own cells. And because they have B, they won't make antibodies to B, so they have no antibodies. At least to A and B antigens. So they might make antibodies against all sorts of other things like chickenpox and that, but they won't make it against the A or the B antigen. And then if you are an O, blood type O, you are not actually blood type O. You're blood type 0, and we just call you O. And if this is your blood cell, you don't have any antigens on your surface, which means that you actually make antibodies to A and B antigens. Okay, now if you have the antibodies plus antigen causes red blood cells to clump. And hemolyze. Okay, this is bad. if you have antibody A and you get antigen A into your blood will clump and hemolyze, and it's bad because it will make you very sick to the point that if you get enough of that happening, you will die. And this is why we can't give blood from anyone just to anyone else. So let's take a look at this. If you are blood type A and we give you A, that's a perfect match. Everyone's happy. If you are blood type A and we give you B, you're going to have the antigen to B, and it's going to clot the blood from B in your body, and that's going to be a negative thing. If we gave you blood type AB, again, you're going to have the antibody against the B antigen. You're going to cause it to clot or clump, and again, that's a negative thing. If you give them blood type O, well, blood type O doesn't have any antigens on it, so it doesn't matter what type of antibody you have, it won't react, and you will be happy. Let's try this all the way down. If we go A, B, A, B, O, A, B, A, B, O, A, B, A, B, O. Okay, so let's go back and look at the B. If you are B type, you have the antigen to A, and if we mix you with the A type, it will clump, and that will be bad. If you're B and you get B, that's a perfect match. You won't have any antibodies against it. You'll be happy. If you are B and you get AB type, though, you're going to be sad because you're going to react to that A antigen on the AB cell. In contrast, if you get O, you'll be happy because no matter what, there's no antigen to react to. Okay, if you're AB and you get A, that's fine because you don't have any antibodies to A. If you're B or AB and you get B, that's fine because you also don't have antibodies to B. And if you get AB, well, that's the perfect match. You're happy. And if you get O, that's the perfect match because, hey, there's no antigens to react to. Because AB can take blood from anyone, we call them the universal recipient. They're happy to get blood from whoever. They're not picky. In contrast, if you are type O and you get A blood, well, you're going to make antibodies against A and going to cause it to clump. If you get B, you're still going to have antibodies to B and clump. AB, double bad luck. But if you get O, well, that's the perfect match and you're happy. Now if you look here, no matter who gets O, they're always happy because O doesn't have any antigen, so it can't create an immune reaction. So O is what we call the universal donor. And if you are O blood type, especially if you're O negative, you are the most popular blood donor that they want to go down to the blood donor clinic and give blood because nobody rejects your blood. So if they have someone who's unconscious in a bad accident, can't say what type of blood they are, and they need to give them blood right away, they want to have lots of O on hand because that's the type they can use no matter what. So that's blood type AB, AB, and O. But I mentioned the idea of being O negative, and some people are O negative or O positive, and the negative or positive refers to yet another protein that's on the cell surface called the Rh protein. Okay. So Rh system refers to a cell surface protein that can cause an immune reaction that was first discovered in rhesus monkeys, and that's why it's called RH for rhesus monkey. RH protein. And if you are RH positive, equals you have the protein. But no antibody against it. This represents approximately 85 to 90% of North Americans. If you are RH negative, it means you lack RH protein, but will make the antibody against it. And this is a relatively, sorry, I don't know why I'm making it beep. This is a relatively small percentage of the North American population, 10 to 15%. But it's quite relevant if you are a female and you are RH negative. Because if you marry a guy or have a child with a man who is RH positive, you have a chance of having children that are born with hemolytic disease of the newborn, HDN. So, what is HDN? You gotta look. It will only happen if female, mother, is negative, and father is RH positive. Okay. If the mom then has a fetus that is RH positive, there is a potential for her body to start producing antibodies against the RH positive blood in the newborn. So normally mom and fetal blood do not mix. It's a misconception. They are not continuous. The fetal blood system is very close to the maternal blood system, and things can diffuse across from maternal and fetal blood from one to the other, but they don't actually mix. And protein, the RH, the cells that carry the RH protein, they shouldn't be mixing with each other. But the birthing process is quite traumatic, and sometimes during birth there is bleeding on both sides from the placenta, fetal blood mixing with maternal blood. Causing mom to produce anti-RH antibodies. Basically, it's the same idea as when you vaccinate someone. You've exposed her to the RH protein. Now, for future reference, her body is going to view that as being foreign and have B cells in it that make antibodies waiting to attack anything that's carrying the rhesus protein. Doesn't usually affect the first child born, but in subsequent births, or pregnancies, RH fetus may be attacked if there's any sort of bleeding and blood crossing and destroyed by mom's Rh antibodies. So in this case, they can do something really cool. At this stage, pregnancy 1, if they find out that baby is Rh positive and mom is Rh negative, before the baby's born, they actually pump Rh antibodies into the mom. Just enough that if any of those plus cells get into the mom, they're bound by the Rh positive antibodies just when they get into the mom. It doesn't cross into the baby. It will stop her immune system. It'll block her immune system from actually recognizing that Rh protein is there, so she won't react to it and start making antibodies to it. Which means when she has a subsequent pregnancy, she doesn't have the antibodies and she doesn't have to worry about them getting in and harming the fetus. Okay? So many of you have asked what blood type you are. One solution for answering this question: become a blood donor. And they will tell you. You can save many lives with a single blood donation, but there's a lot of things that you guys do that actually block you from being able to donate blood. You might want to donate blood, but if you've been tattooed or pierced recently, they actually have a delay for how long you can donate blood afterwards, just because there are various diseases, blood-borne diseases, that you can pick up through tattooing and through piercing. So if you are interested in becoming a blood donor, don't be offended when they ask you to sit down and answer about 50 questions about your lifestyle. There's all sorts of things that can exclude you from being a blood donor. And at the very end, they're going to ask you, do you want to donate your blood? Because some people have been pressured into the situation, and they are asked in private on a little sheet of paper to say whether or not they actually want their blood donated. Perhaps they know there's a reason it shouldn't be donated, but they don't want to tell their friends that reason. So they're going to ask you lots of questions if you want to be a blood donor, but it's a very good thing to do, very helpful thing. Could save someone's life, and down the road it may be something that saves yours. If you have any questions about what we've talked about, please do not hesitate to come see me. Otherwise, I hope you have a good day, and I'll see you in class.